Hello, everybody. My name is Nicholas McKinley. I'm a creative technologies major, and I am also part of the Leadership and Service Fellows Scholarship Program here on campus. And finally, I am a student supervisor for the Berry College Technical Support Desk. So at a very early age in my life, I was very fortunate to have been exposed to the field of STEM. And it was through this early exposure that I found out that my passion in life and purpose was to help others through technology. I would later go on to refine this passion to help others with technology, specifically through the field of prosthetics, where I would set an early goal to eventually one day become a prosthetist. Throughout this journey, I would later go on to Berry College because of its small class sizes and excellent science programs. And because of my background in engineering and prosthetics, I initially enrolled into the dual degree engineering program. After the first semester, though, I would later go on to learn that creative technologies would be a much better fit for me. And it was because of this interest in helping others with tech that throughout my time here in creative technologies, I have made a lot of my projects have been centralized around this one theme. And that theme being developing assistive technologies for individuals with limited mobility. During today's presentation, I will talk about some projects that demonstrate this theme. The first of which being the handless shoe remover. So essentially what this is it is a small wooden box which assists users with limited mobility with removing their shoes. The way that the box works is the user takes one foot, places it inside the box where it says step here. This therefore grounds it and makes it so that it doesn't move. The user then takes their other foot, preferably one with a shoe on it, places it below the 3D printed shoe hook. They pull their leg up, and where the shoe gets caught and comes off. The box also features large bold text to help make the user interaction a little easier. It also features a handle for easy transportation. And finally, it features a push button light on the side for low visibility situations. So in terms of why I would even make a silly box like this in the first place, is there are a lot of simple tasks that you and I may take for granted. These can be getting up in the morning, feeding ourselves, clothing ourselves, taking off our own shoes. And these tasks that we may find simple for individuals with limited mobility or mobility issues, these simple tasks can become Herculean challenges. And it is through this project that I wanted to give these users a way to make these challenges a little easier. I also wanted to do it with relatively simple materials, such as wood and 3D print filament. And I also wanted to do it within the span of 4 hours, as it was a hackathon project. So in terms of how I even made this device, first I went and got some wood. Then I essentially got each piece ready by sanding it, using a panel saw, using a laser cutter to etch the large bold text. Once I had each of the individual pieces ready, I assembled them together using some wood glue and screws, and then I finished the project by adding the features such as the handle, the 3D print hook, and the push button light. So kind of an unexpected result that came from this hackathon project was a newfound interest in woodworking. And it was through this newfound interest that I got to engage in some really cool projects. One of those being a wooden dovetail box. Another thing that I got from this project was the skills and tools that I used to make the handless shoe remover are skills and tools that are often used within the field of prosthetics. And if I continue my journey to become a prosthetist, I will definitely need these skills in the future. In terms of my second theme evidence, I present the ProPrint controller, which this controller is a 3D printed Bluetooth joystick device which assists users when controlling the camera in the 3D modeling software called Fusion 360. The device has three different modes, which each mode changes how you control the camera within the program. The controller also features two big buttons on the sides, which can be mapped to various functions in the program. So in terms of why I made the ProPrint controller, If you've ever used Fusion 360 before, you can tell that the camera can be a little hard to control. And this is especially the case for individuals with limited fine hand motor skills. And one of the reasons why I made this was to allow those people with limited hand motor skills to have access to Fusion 360. Also, if you find that using the trackpad or the mouse can be a little difficult, this can be a great alternative as well. So in terms of how I made this project, I first started off by making a 3D model enclosure within Fusion 360. I then 3D printed it and made sure to get each piece nice and sanded. I would go on to paint them. During the project, I would also use an online software called EasyEDA to design and manufacture a printed circuit board, which was all the technology and how the device worked. Now, it's pretty common knowledge when you're in creative technologies that you often learn that function, at least for the beginning of creative tech, usually trumps appearance. And this is definitely the case for a lot of my projects. An example of one being my CRT 101 final project, where it did function. You can pretty obviously tell that the appearance is a little lacking. One of the things that I learned from the ProPrint controller was not only how to make a functioning project, but how to make it look visually appealing as well. I also learned the skill of PCB design and manufacturing, and considering the fact that PCBs are a common component in many of the prosthetic technology that you see today, this is definitely a skill that I will also need to use in my journey of becoming a prosthetist. For my final theme evidence, I present the prosthetic hand 3D model, which the picture with the darker background is a model that I made, which is a personal recreation or 3D model recreation of Open Bionics' Bruno V2 prosthetic hand. Now, why I made this device in the first place is when I was taking Chris's 3D modeling class, he was talking about the final project and essentially how we could model anything that we wanted. And when he gave us this prompt, I immediately knew, kind of a light bulb went off in my head, and I immediately knew that I wanted to make this model of a prosthetic hand. And essentially why I wanted to do that is throughout my journey of creative technologies and prosthetics, while I had created a lot of projects that were similar to prosthetics and maybe use similar technology, I had yet to create something that was directly relating to the field. And with my newfound skills that I had learned in Chris's class, I finally felt up to the challenge to really try to make something directly related to prosthetics. So in terms of how I made it, since the Bruno V2 prosthetic hand is open source, I went online and found the schematics for the prosthetic hand and a pre-made 3D model. I then used the program Fusion 360 using that schematic and pre-existing 3D model as a reference, where I started off by modeling the palm of the hand to give me a good starting point, where I worked outside, making each individual finger, the thumb, the base of the prosthetic, where I would finish this model by making the individual technological components on the inside. So the man in these two pictures is Kevin Carroll, who is currently the vice president for Hanger Prosthetics, which is one of the world's largest prosthetic fitting companies. Kevin Carroll not only serves as the vice president for Hanger Prosthetics, but has also been a personal mentor and friend throughout most of my journey and experience. And one of the things that this project was able to do was it was able to show him the dedication that I have to this field and what I'm willing to do. And it also showed him that the skills that I'm learning through creative technologies are valuable skills that will eventually help me achieve my goal. Next, I'll talk a little bit about my capstone, which is called the ThermoSense, which is a user-friendly perspiration alert device for amputees. And you may be thinking, why would you make a sweat alertion device? And so essentially for amputees, they face a myriad of challenges every day. Some of these more well-known challenges can include self-esteem issues, phantom limb sense, difficulty completing everyday tasks and challenges. Although I had the opportunity to complete an over-the-summer internship at an actual prosthetic clinic. It was during this internship that I got to learn about a lesser known challenge and issue being heavy perspiration while wearing a prosthetic for amputees. And you may be thinking, Nick, what's the issue with a little heavy sweating? We all do that. But this issue can have some serious side effects for amputees. Some of those being improper healing of the residual limb. It can cause strong odors while wearing a prosthetic, which can make the user anxious about whether or not they'll even wear their device. And the most dangerous of these side effects being an increased chance for the prosthetic to fall off. And so essentially what I wanted to do was create a device to help solve these issues. And when I went on to ask the current prosthetic clinic manager, Brent Clark, what was being done to help solve this issue, he told me that there was a company far away that was producing these prosthetic liners that actually had tiny laser cut holes in them to help the airflow and circulation while wearing a prosthetic. And while he did go on to mention that this was a decent solution, it was a far cry from a perfect solution. And this is what I wanted to do with this device. I wanted to give amputees a way so that they could be alerted of the sweat and then give them a way to deal with that sweat in a way that best suits them. So in terms of how the device actually functions, it utilizes a sensor called a GSR, or galvanic skin response sensor. Basically what it does is it tracks and reads the resistance of your skin. And how it works is the user basically puts it on. They put that on the compression band, they turn the device on, and it takes an initial 100 readings of your skin resistance and creates a threshold. As the user goes about their day, completing labor-intensive activities, moves to a hot climate, that skin resistance number will fluctuate. At any time during the day, if that skin resistance goes down by 200 from that initial baseline threshold for a certain period of time, that will usually indicate sweat. And the way that the amputees are alerted is through a simple vibration motor that is placed in the compression band. So this capstone project was broken up into 6 different sprints, each being 2 weeks long. For the first milestone, this was about research and development. So essentially what I did was I researched how big the device would need to be, how heavy it would need to be, and make sure that it was comfortable for an amputee. And this is also where I made my very first low fidelity prototype to ensure that this method of sweat detection would actually work. For milestone 2, this is where I designed the PCB, essentially the technology, and the enclosure that would house the technology. I had Zane order the PCB, and I manufactured it and soldered it. I also 3D printed the enclosure that I had designed, and this is where I assembled the very first version of the ThermoSense. For milestone 3, this is where I did initial product testing and editing. So I tried out that first iteration of the ThermoSense on myself, close friends, and family. After I got that, I gathered data on their experience with this first version and used that to make very small edits to this version of the ThermoSense, where I would ultimately get the first user-friendly version, or the first prototype version. For milestone 4, this is where I conducted amputee testing phase 1. I was very lucky to have a gentleman who was an amputee who did experience heavy perspiration be willing to try out my silly little product. And so essentially how the testing phase went is I gave him the ThermoSense for 1 week to wear it, and he could wear it for as little or as much as he wanted. After that 1 week, I would retrieve the ThermoSense again and interview him on his experience with the ThermoSense. For milestone 5, after interviewing the user, I took their feedback and made some final iterations and changes to the ThermoSense, getting the second quote-unquote final version of the ThermoSense. And in terms of how I ended off my capstone, I conducted amputee testing phase 2, where I gave the same user the final version of the ThermoSense. After that 1 week, I retrieved the product and similarly asked them their experience with the new changes that I had made to the device. So at the beginning of this capstone, I had created some design goals to help me track and determine the success of this project. The first one being, this project will identify when the wearer starts sweating through changes in skin resistance. So essentially, will this device even work at all? And during the first user testing phase, the device actually didn't work as intended. While it did, or while it was able to successfully detect when it was sweating, since the vibration motor was actually still inside the enclosure, which was placed at the bottom of the prosthetic, the user was not able to feel this vibration. I'm happy to report that after making some changes and moving the vibration motor to the compression band where it had direct contact with the skin, the user did report that they did feel vibration, and they did report that this was while they were sweating, indicating that I was able to successfully complete this design goal. For design goal 2, this project will develop a wearable enclosure that ensures comfort and durability for the user. This design goal was especially important, for when you're making a prosthetic or prosthetic accessory, comfort is crucial as it can immediately determine whether an amputee will even wear this device in the first place. So during my user testing phase, the volunteer actually said that they felt more comfortable during testing phase 1. For the second iteration, there was some more wires, and in the first version, it was a little more simple, so that's why they felt more comfortable. During the second testing phase, that's where it produced a little more challenges. Some of the wiring was made the device a little difficult to wear. Also, with the new technology, it made the device come apart, and it did have to be Velcroed back together. When interviewing the user and asking them to rate the comfort on a scale of 1 to 5, they gave the device a solid 3. So it was comfortable enough to wear for long periods of time, but not something that they would wear 24/7, and it was something that they didn't notice that they were wearing. My final design goal was this project will enhance prosthetic comfort for amputees in challenging conditions. So I essentially wanted to look at whether or not this project was even worth building and making, and whether or not it would actually solve this issue. When I interviewed the user on the final verdict of the ThermoSense, here's what they had to say. The user thought that the device was headed in the right direction and could definitely be useful for people like myself, but it needed some polish. And for me, being able to hear from an actual amputee who did experience this challenge, that this device could even be minusculely helpful, or could even be a little bit helpful for them, really showed me that I'm headed in the right direction and that this device can actually make change for amputees. And in terms of the polish, that's something that I can get in future iterations. So in terms of the impact that this capstone had on me, it was a huge contributing factor of why I was able to be accepted into Kennesaw State's Masters of Science in Prosthetics and Orthotics program for graduate school. Students in this program are required to conduct a research project, and I would like to continue my production and development of the ThermoSense as my research project. I also learned valuable ways and methods to which I can improve the ThermoSense, where essentially how I want to make it better is to integrate it into the liner, which will overall increase the user experience, making it a little easier to use, and will also definitely increase the comfort of the device. In terms of future outlook, as I just mentioned, I was accepted into Kennesaw State's MSPO program, so I will be spending the next 2 years of my life learning everything there is to know about prosthetics. And thank you for watching my presentation, and I hope you guys enjoyed.